Hello everyone, welcome back to Advent of Code Day 6. Wait for it. Well, you don't need to wait for it. I'm here to give you the solution and the bad jokes accompanying it. But regardless, Advent of Code 2023, Day 6, wait for it. We are solving it in Rust. And I know this is sort of my first Advent of Code video. That is because I had not found the time to record for day 1 to day 5. But here I am with day 6, Advent of Code. I just solved this about an hour or so ago. So, uh, yeah, with that, let's get started. But for the uninitiated, I'm solving Advent of Code for the first time this year, and I'm doing it in Rust because I really want to learn the language. And I've set up some ground rules for myself, which are just three that I'll quickly go over. Number one, I'm not allowed to use any parsing libraries like Norm or even use regex because I want to learn tokenization and how to actually parse through the input. Second up, I'm allowed to use GitHub Copilot auto completions, but I'm not allowed to directly ask an AI questions related to the problem. So I cannot directly ask ChatGPT to write code for parsing the input, right? But if I'm, let's say, writing it on GitHub Copilot suggested, I am allowed to review it. Third one is I am allowed I'm allowing myself to submit any number of times before I call it quits. So even if my first attempt is wrong, I'm allowed to do it for the second one. So with these three ground rules out of the way, I've written the code for day 6. So let's get into day 6, the part 1, part 2, the problem, and the code walkthrough and explanation. I'm not going to actually code in front of you guys. You will have to join my live streams for that, but which I'm planning soon. But this is just a code walkthrough, and I'll let you go through. I'll teach you the whole process of it basically. So, day 6, wait for it. So, till day 5, if you don't know, we are basically searching for sand at this point. Just keep that in mind. And we are taking a ferry that goes across island and island. I highly suggest you read through the stories, they're really fun and interactive. So, after asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see it anywhere besides lots of water and the small island where the ferry has stopped. We have come here by ferry, by the way. As you try to figure out what to do next, you notice a poster on the wall near the ferry dock. We sure do get distracted a lot. Boat races open to public. Grand prize is an all expenses paid trip to Desert Island. And we want to go to Desert Island because we want the sand. Right. So we sign up for the boat competition, and the boat race basically is in the shortest amount of time you want to travel the best distance. Right. So, and these are all toy boats. So the organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats. And the way these toy boats basically work is apparently you hold down a button, sort of wind the toy boat up as it goes through the water, which I actually like the idea of it. So here's the deal. Uh, let's say I have a boat. Let's actually use the input. Let's say I have a boat that takes that the race itself. So the time and distance, if I can actually read over here, as a part of signing up, you get a sheet of paper that is your puzzle input that lists the time allowed for each race and also the best distance ever recorded in that race, right? So you get a list of time allowed for each race. So the race you can only participate in it for 7 milliseconds, and 9 millimeters is the largest distance that a boat had ever gone before, and you are supposed to beat the record in every race, right? So for example one, right, the lay race lasts for 7 milliseconds, and the record distance is 9 millimeters, and we need to beat this record. Now, the boat intrinsically has three properties, right? Speed, time, and distance. We want to find the distance such that it is greater than the recorded distance. Sounds simple enough, right? But here's where there's a little bit complexity involved. The boat by default doesn't have a speed. The starting speed is 0 millimeters per millisecond. Now, ignore the milliseconds and millimeters, they have no role to play. It's all abstracted away. So the so we basically are given the time, we are given the greater than of the whole event, and all we are supposed to find out is the range, right? So for the initial race, which lasts for 7 milliseconds and is for 9 millimeters, let's say we hold the button for 1 millisecond, right? We hold it for 1 millisecond, our speed is 1 millimeter per second. But we have already spent 1 millisecond of the time holding down the button. So we only have 6 millimeters left. So we can travel a total of 1 into 6, which is 6 millimeters. If you remember the equation, speed is distance by time, right? Speed is distance by time, right? So remember that. So to find distance, you multiply the speed and the time together. So let's say we hold down the button for 4 milliseconds, right? So our speed is 4, and the boat has a remaining time of 3 milliseconds to travel. So the boat has gone for 12 millimeters. Sounds simple enough. So we are only supposed to find this. So since the current record of the race is 9 milliseconds, there are actually four different ways in which you can win to hold the button for 2, 3, 4, and 5. Right. So for the first race, which is 9 and 7 and 9, we have four ways to win. The second one, we have 8 ways to win. And for the third one, we have 9 ways to win. And all we have to do is multiply them together. Sounds simple enough. So as you can see, I got the answer. So now, hopefully, since you guys have understood that, hopefully, let's get into the code. So this is the code for part one, right? Our input is in the temporary file. This is how I like to structure my files. Basically, each day is a separate cargo project that has a bin directory of part one and part two. And for reading the input, I know a good way is to include the file itself, like the read from the file, but I just like to include the file because we are using Rust. Why not use its features, right? So this is our input. Let me paste this up here so that I can refer to it easily, or let's just keep it there, right? So first things first, let us turn on send mode, right? So first things first, we have the main function, right? This is part one. The main function, first we need to read the input. Now, reading the input is quite simple. We just include the string and split the lines, right? So include string of temporary, in this case, input is the actual test input given to us. We want to split that into lines that returns a line iterator that has string slices in it. We map over them and convert each of them to a string. And now, since this is still an iter item, we want to collect all the iter items into a vector of strings. Now we can probably work off of string references, but for like script like problems in Rust, I prefer working with strings, which are whole objects rather than the references, right? And objects is a very bad word, I know, but still. Next, we have times. Now, the way I pass times is, here we go. Let me actually comment over the whole thing and show you how we are actually parsing the times. Uh, right, let's go one by one here, shall we? Let's focus just on times. Let me print out the times for you. Right. Let me print over the times. There we go. Open up our console here. And here I say cargo run dash dash bin part 1. So there you go. We have passed the string, the times. How did we do that? Well, basically, first we split the input, the first entry of the input, right, into a split, which returns a split iterator, right? Now the split iterator we are filtering, and we are filtering by is numeric because we only want numbers, and this is numeric is a function I wrote. It basically tries to parse the number into an I32 and returns if it was able to do it or not. If it was, it returns true. If it isn't, it returns false. And we are filtering uh, each and every sort of entry in that split iterator for a number. And if it is a number, we are quickly parsing it to be a number and collecting it into a vector of numbers, right? Similarly, we are doing the same thing for the distance. So now we have a set of times and distances. And if I print that out here quickly, allow this to happen. And I quickly go times and distances, run that. As you can see, I have the times and the distances. Really cool, really awesome. But we don't prefer it to be in a format like this because it makes it really hard to operate with. So I prefer to use something called zip. Now zip is a very special iterator function in Rust. I love it because you can just pass in two iterators to it. Pass in the sense you can sort of call it upon an iterator, and all it does is basically map it up, right? So if I print that out now, we have beautiful pairs. Cool. Now, with that done, now that we have the pairs, all we have to figure out right now is to understand what entails a winning pair, right? So we have a function called getWinning that takes in a pair. Remember the pair we just passed? That this function takes that in and returns all the winning objects, right? So we first destructure it, destructure the pair. We need the time and the record, and the result is a new vector that we can keep it to a side. Now, for I in the range of 1 to whatever the maximum time is. So in this case, it will be, let's say, for I in 1 to 7, right? Something like that. Now, I want you to observe one thing carefully. Our I is basically our speed. Am I right? Because I we skipped over the 0th case. So the case where the speed is 0 is completely gone, right? So we have that. Now we have I as 1, which is our first speed, right? So the I is basically the speed at which the boat is going. So the amount of time we are holding the boat down is represented by this I, right? So what is the distance? The distance is basically I multiplied by time minus I, right? Because you're pressing the boat down for I seconds, that is giving it the speed of I, and you're subtracting the amount of time you have held the boat down from the initial time variable time, right? So we get the distance. Simple. So now if the distance is greater than the record, you push the record and you finally return the record. How simple is that? So now if I run this, as you can see, we get a distance of 50, 54, 56, 56, 54, 50, 44. These are all the distances for different ones of these. And we get the correct answer, 288. Right? We get the right answer. So with this, part 1 is done. As simple as that. So I've got the output, entered the output, and it accepted it. Well and good. Now it is part two. Part two is where it gets really interesting. The whole question is basically the same thing. However, I want you to observe your input, which if my internet allows me to open up, there you go. So this is our input, which 62 and 644 are relatively smaller numbers. We do not need a complex this thing to go through it. We can just use the newbie approach of using an iterator. What we are doing here, what we were doing till now, is basically using an iterator, right? We are using iterables everywhere. We are using a for loop here. We are using a for loop and we're basically iterating over stuff. And this is quite inefficient code. So what Advent of Code is asking us to do, basically by giving us such larger numbers, is asking us to optimize our solution. What do you mean by large numbers? You see, for part two, we need to ignore the spaces. So that's something called kerning, apparently. I learned it today. I'm proud of that. But you're supposed to remove the spaces. Now, these large numbers are not, it's not recommended you iterate over them at all. This would provide such a huge number that I'm sure even an I-32 will not be able to hold it, nor will a U-32. I will be needing a U-64 or an I-64 to hold this. So this much of a large number, you iterate over it. Best of luck running your program. And if you're doing this in a language like Python, I wish you all the best. So we need to find a more efficient method. And this is where I invite you guys to stop looking at it programmatically and start to look at it a little bit mathematically. Right. So this is where it gets really, really interesting. So I think I can give a mathematical demo at this point. Let's see if that is even possible. Uh, so hopefully you're able to see the R notes. Here we go. So here's what I want you to imagine. Right. We have we have 15. Let's choose a better color. We have basically 15 and 40. Right. And our equation is V is equal to S by T, right? And we need to find this condition where S is greater than, or actually it's not even greater than, it's just greater than 40, right? So this is how you can mathematically represent this equation. So what is our S now? S is V into T. But what did we discuss V to be? V was 1. V was I, remember? In our iterations, V was I. And what was T? Sorry. I'm telling it all. Oh no. V was I. We are doing it right. V is I. And the T we discussed was the total time given minus I. Right. So what we essentially are doing is I into T minus I is greater than 40. Right. And what does this look like? This is a quadratic equation in one variable. So basically 15I minus I square minus 40, right, is greater than 0. And this is essentially what our whole programmatical problem boils down to: simple quadratic math. So I hope you guys all remember how do you solve ax square plus bx plus c is 0. Yeah, you basically take minus b plus or minus root times of b square, which is 225, minus of a 4ac, which will be 4 into minus 1 into minus 1 into 40, which will be minus 160 by minus 2. And this one can be written as minus 15 plus or minus root 65 is approximately like 8.1 by minus 2. So this is greater than 40, mind you, right? Actually, this is the right representation. X minus this is greater than 40. So essentially, x belongs to, let me write that down in a good place. So essentially, x belongs to closed range. Since it is not equal to 40, closed range minus 15 plus 8 is what? Minus 7. Minus 7 by minus 2 is 3.5. So x belongs to closed range 3.5, comma, minus 15 minus 8 is like minus 23 by minus 2 is 11.5. So this is what our answer is. The range of this is our answer. And you want to verify that? Just check the solution. See this? Where is that? Here we go. 8 is at least 4 and at most 11. Right. So essentially, all we have done is I'm sure you guys are aware of a mathematical concept called ceiling and flooring. Now, flooring uh, is going to the is basically discarding the decimal digit is what it is, right? And ceiling is going up a number. So the floor of 3.5 is 3, whereas the ceiling of 11.5 is 12. So this is essentially what he did. All the numbers between the range of 1 to time that are also in the range of this x are the ones that are greater than the distance. That is as simple as that. And I hope you guys understood this. If you didn't, I suggest you go back and review this thing. Basically, review the math I just did. But welcome to part two. Now we'll be delving into this disclaimer I wrote out for you guys in a second. But let's go to the main function first. Everything remains the same. We still have the input, we still have the times with a very small change in the way we parse it. We now parse all the characters instead. So T, I, M, E, so and so on. And if it is numeric, we directly add it, right? You can probably write this out in a while loop. If you're a for loop, if you're a beginner, I know you guys prefer a for loop. So this is how you can write it. You can just say like res is something like this. You can just say string dot new or something like that. Make it mutable. And for like t and times, if t dot is oh sorry t dot times dot chars, or no, uh, input input of 0 dot chars, if t dot is like numeric, res dot push the t, right? So I've just essentially converted this into a more rust like form. That's it. I'm sure you guys will understand this. So we have the times and the distances that are in the pair. Perfect. Now the get winning, as I showcased earlier with the math equation, this is our math equation. Minus I to the power of 2 plus time into I minus record is 0. Now, this is where stuff gets a little funny because we are working with extremely large numbers that we are taking square roots of, we are taking decimal points of, and it basically becomes a big whole mess. So, I've essentially just converted the b square minus 4ac into the formula here, like time power 2 minus 4 into record square root of that. So I get the square root of it, right? Next, the result is a string of two numbers, basically, plus or minus. That's why it is a array of two numbers in F32, right? So time as F2 plus the difference by 2, since the minus minus get cancelled, and the time as F32 minus the difference by 2. Now, since we are dealing with negative numbers, you might be asking why not just take the plus as the minimum number and the minus as the maximum number? And it might work, but since we are working with very large numbers whose square roots we are not familiar with, it is preferable if we leave it up um, to the computer to decide which is greater, which is essentially what we did here. So the minimum number is, we are first iterating through the res array, the slice to be precise, the slice of res, and we are minimum by. We are taking the minimum value with respect to a specified comparison function. Now, Rust by default provides the minimum function by default for only the U to I series. The floats are not provided with the minimum function by default, so we have to provide it. We are passing in X and Y. We are partially comparing this, and the partial order exists by default for most of the Rust types, which we are just using in this. So we are doing that. We are doing that to own, and we are sealing the minimum number, right? We are sealing it. We want the one, we don't want numbers that are before this. We only want the ones that are after this. Because if you remember the mathematical formula, it was finally something returned something like x belongs to closed brackets minimum number and maximum number. It had not returned as open brackets, so we are not supposed to include the minimum number and the maximum number in our calculations, and if we did, that would lead to errors. So we are not including that. We are doing the same thing for the maximum number. And now this is where I want to discuss this comment. Right. So we are dealing with extremely large numbers. Extremely, which I'll be showing you shortly how extremely large they are. In these, we are taking F32. Right. The thing about F32 is that it can hold up to 7 digits, if I'm right. 7 digits is a lot, but it's not precise. I mean, don't get me wrong, 7 digits is very precise for a human, but when you're flooring and sealing it, it's not really precise. So what happens is, we are sealing stuff, we are multiplying stuff, we are doing so many things. Sometimes our answer is off by a digit or two. Not a digit, a number or two. So let's say if the answer was 10,000, this program might return 10,001. Is there an easy way to check for it? Yes, you just put in a while loop. What is our condition? The minimum number, right? The minimum number should always be greater than the record, right? Because we want to check what is the least number in the range of the time frame that the we actually cross the record, right? our distance actually crosses the record. So we don't want this condition. This is the condition we don't want for our minimum number. And whereas in the case of the maximum number, this is the condition we don't want for our maximum number, because if our maximum number is less than the record, how is that the maximum number? We want it to be greater than the record. So while these both wrong conditions are true, we are adding and subtracting it respectively. Right. And then we are printing it out just for reference sake. And we are giving the range. Now, if you remember your math classes properly, the number of numbers in range x to y is y minus x plus 1, right? So if I ask you for the amount of numbers from 1 to 10, the answer is not 10 minus 1, 9. It is 10 minus 1 plus 1, which is 10. It's the right answer. So we are adding this plus 1 and we finally get our answer. So if I open up our terminal and say cargo run bin part 2, this is the amount of large numbers we are dealing with, right? And this is our range. Now imagine iterating through this, right? In this case, we are not doing anything. There is no iteration involved whatsoever. It's a simple mathematical calculation. This program runs in milliseconds. It doesn't even take a moment to process stuff. And that is the power of using mathematics and programming. We probably could have done this programmatically using a programming concept, but math just made it easier, right? So this is how you solve day 6 of Advent of Code. These solutions are available on my GitHub. Be sure to check it out. If you have not understood any of the concept that I've basically told about, uh, please feel free to reach out to me. I would love to uh, get in touch. And yeah, this is my day 6 solution for Advent of Code. And please don't feel pressurized that you have to implement it in Rust. I have implemented it in Rust. I'm sure if you use this exact concept in Python, you can get it done in like far less lines of code than I have. Right. I'm sure Python, you don't need to worry that much about I64s and U32s and float 32s. Right. You can just give it the equation. As simple as that. So let me know, post your solutions in the comments. I'll be pinning the interesting ones up above. And thanks for watching. Hope you had a great time and happy learning. Bye bye.